Namaste, my friend, and welcome to JEE Physics with Typical Monk. Now this is class 1, and we begin with something so simple that most students rush past it and then lose easy marks for the rest of their lives. Every number in physics carries two hidden companions, a unit and an error. 9.8 means nothing until you say meters per second squared. And no measurement is ever exact. Every ruler, every clock, every instrument tells a small honest lie. When Sarah first solved a JEE numerical, she wrote the right formula and still lost the mark because she ignored the units and the error. Today, we fix that forever. And here is why this matters more in JEE than in NEET. JEE Physics is built on calculus, and even the error in a formula is found using calculus. Take a slow breath. Let us begin. So what will you carry home from today's class? First, the 7 psi-base units and how every other quantity is written as their MLLT fingerprint. Second, dimensional analysis, how to check an equation, derive a relation, convert units, and exactly where the method fails. Third, significant figures and rounding, the honesty of a number. Fourth, error propagation, how errors travel through sums, products, and powers. And here we meet the calculus that JEE loves and NEET skips. And fifth, least count, the vernier callipers, and the screw gauge, and the JEE drills that turn all of this into marks. Ready? One idea at a time. Let us start at the foundation. Physics rests on just 7 base units: the kilogram for mass, the meter for length, the second for time, and then the ampere, the Kelvin, the mole, and the candela. Everything else, speed, force, energy, is derived from these. Now, the beautiful idea. Any quantity can be written as mass to some power, times length to some power, times time to some power. We call this its dimensional formula. It's MLLT fingerprint. Take force. Force is mass times acceleration, and acceleration is length over time squared. So force is MLT to the power minus 2. That is the fingerprint of every force in the universe. And energy, which is force times distance, becomes mls squared t to the power minus 2. Here is the payoff. Work, heat, and torque all share this fingerprint, which is exactly why they can be added together and compared. Same dimensions, same family. Look at this map carefully because it shows how quantities grow out of one another. In the center sits velocity. Velocity is length divided by time, Lt to the power minus 1. This is where we begin. Divide once more by time, and velocity becomes acceleration, Lt to the power minus 2. Each division by time drops the power by 1. Now go the other way, multiply velocity by mass, and you get momentum, mLt to the power minus 1. And multiply force by distance, and you reach energy, ml squared t to the power minus 2. David used to memorize every fingerprint separately and kept forgetting them. Today he learned to walk this map, building each quantity from velocity. He never needed to memorize again. Now, what can this fingerprint actually do for us? And, just as important, what can it not do? First, it checks an equation. Every term you add must carry the same dimensions, so both sides of a correct equation must match. If they do not, the equation is wrong, no calculation needed. Second, it derives a relation. The period of a pendulum, for instance, comes out as some constant times the square root of length. Over gravity, dimensions alone reveal that shape. Third, it converts units across systems because the powers of m, l, and t carry the conversion for you. But now the honest limit, and JEE tests this directly. Dimensional analysis can never find a pure number. That constant in front, the 2 pi in the pendulum, is invisible to it. And it cannot check the inside of a sine, a logarithm, or an exponent, because those must always be dimensionless. Lisa lost a full question, assuming a dimensionally correct formula was complete. It was missing a factor of 2 pi. Time to solve a full JEE numerical, together, slowly. The monk's way. We measure gravity with a pendulum. The length is 100.0 centimeters, give or take 0.1, and the time period is 2.00 seconds, give or take 0.01. Gravity equals 4 pi squared L over t squared. Find the percentage error in gravity. Step 1. Write down what is given. Length 100.0 plus or minus 0.1 centimeters. Period 2.00 plus or minus 0.01 seconds. And gravity equals 4 pi squared L over T squared. Step 2. The formula for the error. Because time appears squared, its fractional error is doubled. So the fractional error in gravity equals the fractional error in length plus 2 times the fractional error in time. Step 3. The length term. 0.1 divided by 100 is 0.001. Step 4. The time term. 2 times 0.01 divided by 2.00 is 0.010. Notice the time error dominates because it is doubled. Step 5. Add them. 0.001 plus 0.010 is 0.011, which is 1.1%. That is your answer. And notice the whole method. Given, formula, each term, then add. The same for moves, solve every error numerical JEE can ask. Now, the instruments themselves, because JEE loves to ask how precisely you can actually measure. First, the vernier calipers. Its least count is 1 main scale division minus 1 vernier scale division, here 0.1 millimeter. That is the smallest length it can honestly resolve. Second, the screw gauge, which is finer still. Its least count is the pitch divided by the number of circular divisions. Here, 0.01 millimeter, 10 times sharper than the vernier. Third, how errors travel. For a sum or a difference, the absolute errors add. For a product or a quotient, the fractional errors add. And fourth, the JEE favorite, a power of n multiplies the fractional error by n. And before any reading, always check the zero error. The lie the instrument tells even when it is closed. John forgot the zero error once, and every single reading in his experiment was wrong by the same amount. Now sit up straight. These 5 lines are what JEE actually asks year after year. 1. Force is mLt to the power minus 2. Energy is ml squared t to the power minus 2. And pressure is ml to the power minus 1 t to the power minus 2. Know these cold. They should come faster than your own name. 2. The argument of a sine, a logarithm or an exponential is always dimensionless. This one check has decided whole questions. 3. In a power law, the exponent multiplies the fractional error. A square doubles it, a cube triples it. 4. For maximum error, the fractional errors always add, never subtract, not even when the quantity is in the denominator. 5. A result can never be more precise than its least precise measurement. Significant figures are honesty in numbers. Let us drill the JEE way. Remember the 4 options. Option A, both statements true, and the reason explains the assertion. Option B, both true, but the reason does not explain the assertion. Option C, assertion true, reason false. Option D, assertion false, reason true. First one. Assertion. Dimensional analysis cannot derive a formula that contains a pure number. Reason. A dimensionless constant has no mass, length, or time to track. Think like Sarah. Check each statement, then the connection. Is the assertion true? Yes. Is the reason true? Yes. And does the reason explain the assertion? Perfectly. A pure number is invisible to dimensions precisely because it has no ml or t. Both true. Reason explains. Option A. Second one. Assertion. The percentage error in a squared quantity is double the percentage error in the quantity. Reason. Absolute errors always add in a product. Both statements are true. But pause. Does the reason explain the assertion? No. The doubling comes from the power of 2, from the exponent rule, not from absolute errors adding. Both true, but the reason does not explain the assertion. Option B. This is the trap that catches John every time. Third one. Assertion. The number 2.50 has 2 significant figures. Reason. Trailing zeros after a decimal point are significant. Check the reason first. Trailing zeros after a decimal are indeed significant. True. Now the assertion. 2.50 therefore has 3 significant figures, not 2. The assertion is false. The reason is true. Option D. A quick match now. Say each fingerprint aloud before I reveal it. Force, mLt to the power minus 2, mass times acceleration. Energy or work, mL squared t to the power minus 2, force times distance. Pressure, mL to the power minus 1, t to the power minus 2, force divided by area. And power, mLl squared t to the power minus 3, energy divided by time. One more division by time than energy. If all four came to you before the reveal, the map is becoming yours. Use a favorite G format. I will read some statements. You silently count how many are correct. Statement 1. Work and torque have the same dimensions. Hold your verdict. Statement 2. Dimensional analysis can find the value of a dimensionless constant. Think of the pendulum before you answer. Statement 3. The number 0.00340 has 3 significant figures. Count only from the first non-zero digit. So, how many are correct? 2 statements, the first and the third. Work and torque truly share the fingerprint ml squared t to the power minus 2, and that number has 3 significant figures, 3, 4 and the trailing 0. But the second one falls. Dimensions can never find a pure number. 2 correct. And the middle one is the trap. Now let me save you some marks. 2 myths that trap thousands of students every year. Myth 1. Errors in a division subtract because one quantity sits on the bottom. It feels so natural. Surely dividing cancels some error? But here is the truth. For the maximum error, the fractional errors always add, top and bottom alike. Division never reduces uncertainty, it only combines it. Myth 2. If both sides of an equation have the same dimensions, the equation must be correct. The truth, dimensional consistency is necessary but not sufficient. It cannot see a missing pure number, and it cannot catch a wrong extra term that happens to share the dimensions. One myth, one 4G question, do not let it be the one that costs you. Time to test yourself, rapid fire, and every answer today is a number. Here is the rule. I ask, you answer in your head before the reveal. No pen, no paper, just what you built today. Question 1. What are the dimensions of pressure? Force over area, ml to the power minus 1, t to the power minus 2. Question 2. How many significant figures in 0.02300? Count from the first non-zero, 4. Question 3. If x equals a times b squared, a has 1% error and b has 2%, what is the error in x? 1 plus 2 times 2, 5%. Question 4. A screw gauge has a pitch of 1 mm and 100 divisions. Its least count? 1 divided by 100, 0.01 mm. And question 5. The thinker. What are the dimensions of the gravitational constant g? From gravity equals gm1min2 over r squared, solve for gm to the power minus 1, l cubed, t to the power minus 2. If you caught that one, you have truly understood today's class. Let us gather the whole class in one slow breath. 7 SI base units build every quantity's MLT fingerprint. Dimensional analysis checks equations, derives relations, and converts units, but it can never find a pure number nor look inside a sign or a log. Significant figures keep us honest. Our result is only as precise as its weakest measurement. Errors travel by simple rules. Sums add absolute errors, products add fractional errors, and powers multiply the fractional error by the exponent. Least count and zero error decide exactly how far a vernier or a screw gauge can be trusted. And next class, we begin motion itself. Kinematics in one dimension, velocity and acceleration as derivatives, and displacement recovered by integration. This is where the calculus truly begins. Do not miss it. And so, my friend, we have taken the first step. It may have looked like just units and small errors, but understand this. This is the grammar of all of physics. Every formula you will ever write, every numerical G will ever throw at you, rests on the units, the dimensions, and the honest error you learned to read today. Sarah, David, Lisa, and John all started exactly where you are right now with this one class. Be patient with yourself. Tonight, revise the error rules once. Slowly, sums add, products add fractional, powers multiply. One idea at a time. You'll crack JEE. Of this I am certain. If this class brought you clarity, subscribe to the channel so the next one finds you. Until then, keep going. I will see you in motion.